I'm going to tell you a bit of a story, because the story that started maybe 3-4 years ago. I was not really much into AI at the time when I joined this large-scale development program. You can see it in my LinkedIn what it is. I cannot say it. And this is kind of a story in two parts. Yeah. So the first part is, what did we do for this large-scale development program? And we have achieved quite a lot there. But this was not AI-driven. This was essentially large program development. No? And it's a large consortium, several countries, Germany, France, Italy, Spain, hundreds of people, close to 1,000, and we had to put everything together. And the first part of this story is, how do we put that together? And we were able to put it together. Now the question is, AI has entered the scene maybe 1 year ago for me, 1.5, 2 years ago, let's say it like that. Yeah. And I'm a software engineer by education, and I have a PhD in computer science. So I'm a software guy. And of course I was fascinated by it. Yeah. So I started doing my own stuff on the side. Yeah. What can I do with it? Yeah. What can I build? Yeah. And I went much further than I thought I could with it privately. And now the story is, how do these two things come together? Yeah. How do you? And of course there is the story of the company itself. What is the company doing in this direction? I will not go into any details of that, but we're at the beginning. But being a software guy and leading a software team, software department, you have to ask yourself, why are we not using this stuff yet? Because I see that it goes so fast, and on the other hand, I see that we're developing software traditionally, which lots of people still are. And this presentation has a lot of questions, but I think that is actually where I am at this point with this story. And I think nobody knows where this is going, to be honest. Let's be honest. Yeah. You don't know. A year ago, I didn't know where it will be today, and we don't know what it's going to be in 1 year. No. So I think questions are granted at this point. Okay. So just who we are very quickly. I started this team. I built the whole software. The team built the whole software that now is actually serving the whole program. We do releases every 2 months. It's a big product now. It serves hundreds of people. And Julius is in the audience also. He's one of the main architects of the whole thing. He wrote a lot of this stuff. And so go and talk to him also afterwards. Okay, so where does the story start? Yeah, the story starts actually from systems engineering side. So these large development programs have a very long tradition of development. And it's typically kind of a waterfall, although now it's kind of, we try to go into the V, etc., but it's still it takes a while. Everything is kind of waterfall. You expect that you do this first, and then you do that after, and then you do that after. And then we started using systems engineering. It was in that direction where we tried to formalize things a little bit more, because in the past there was a lot of stuff that was just Word, doors, Excel. And afterwards, say 20 years ago, then things started to go a bit into the direction of doors more. And then in the last few years, then we started to go more into systems engineering, because this is a discipline that is relatively well explored, let's put it like that. And it was said, well, if you do systems engineering, then we can do this much faster. So we try that. The part that my team started to support, and this was the big problem that we had at the beginning, was that, you're like, okay, let's do systems engineering. Great. Here's some tools. Now do systems engineering. It doesn't work, because people, how do I take this data and put this from this tool into the other tool, and then how do I put it in the other tool? How do I cross-check? How do I generate artifacts, etc., etc. And that's where we came in and we said, okay, I mean, you can do the systems engineering stuff. We will do all the development under to make sure that this happens, that this is possible. And that's where the software product comes in. So we cover those parts: systems engineering definition, architecture definition, lots of SysML, Cameo, for those of you who know that, design definition, etc. And at this point, we do that quite well. I mean, we were able to build a whole set of tools that were actually homegrown to do this stuff. But we kind of reached limits relatively fast, because we thought, well, we are doing systems engineering, and there's a lot of people talking about systems engineering and saying, well, you do it like this, you use this method, you use my process is great, etc., etc. Yeah, sure, but under the hood, how do you put those things together? And we realized that then you have to go basic to the infrastructure, the whole infrastructure running underneath. You have to go to the virtual machines, you have to go to the software running, you have to go to the databases, you have to cross-check those databases, you have to make all of that work. Yeah? So we realized that actually, and this is kind of an entry into the AI problem, is that people talk a lot about AI right now, but there are even problems with just basic digitalization. How do you put the stuff together first? I mean, you can have a bunch of tools, and the vendor comes and says, I have this great tool here for you. And you get some champion, and the champion puts the tool inside, and then what do you do with it? It has to be customized, it has to be learned, it has to go into the process. So all of these things, and we have, at this point, hundreds of tools. Some of them are bought, some of them are homegrown. And then, actually, I say this often, but I say it because I think it's true, is that sometimes we would be better off, or, I mean, this is a bit of an excess, but why don't we use Google Docs? Because if you have the tools, if you have 100 tools and you have data in 100 tools, and then you don't know how to put this data together, why don't we use Google Docs? Because in the end, airplane development is actually document driven. So in the end, you have to have some documents to present to the authorities, and they will say the plane can fly, cannot fly. I mean, of course, I'm exaggerating here, but we are in a certain point where we have way too many tools, way too many data formats, way too many silos. We are big, we are very big, which means that we have departments for everything. And then everybody in their own department will have their tool because they bought it or because somebody did it. And they say, well, the tool here has the right data. This is the good data. You are wrong. No? And then how do you bridge this? It's very hard. It's really very hard. So this is kind of the problem that we try to solve, yeah? And we found many problems at all levels, and we were able to solve many of them, yeah. So I just put a few of them here for you to know, because the talk is about a large scale project, and what are the challenges that we met? Yeah, so we need to manage the models at scale. Yeah? So you have models of requirements, you have models of the design, you have models of the breakdown structure, you have models of the electrical part, you have models of the mechanical part, and you have to put all this stuff together. Yeah? So how do you manage this? Because all the models are probably in the tool that is preferred by that person or by that department, yeah, and they don't talk to you necessarily. Yeah? So you have to kind of, go in that direction and say, let's make an API here, let's wrap this up somehow. Yeah, not easy. Yeah? Sorry. Need to handle the anomalies at scale. Yeah, so you have a big program. You have hundreds of people. You are defining systems that interface with each other. These systems will break at the interfaces, necessarily. Yeah? Not because people are mean or because they don't want to do it right, because there will be miscommunications. And if you have hundreds of people working on 10 databases, how do you make sure that the interfaces are not broken? It's a huge problem now. You need to manage the users at scale. What does this mean? It means that if we have a product, we have to serve the product. If we serve the product, people will come to us and say, your product is not good. It's broken. Fix it. And at the beginning, we had a lot of that. I mean, at some point, I was basically help desk. Yeah, I was there all the time, just answering calls from people until we got something running. And then you need to somehow coach the people into believing that your system is working, such that they then go into your direction. And this takes years, so that people trust you. You need to manage data exchange at scale. So you have large amounts of data, millions of elements. How do you manage this? You need to manage variants. So you have the German airplane, but you have the Italian airplane, and you have the French airplane. These are different airplanes, and you need to manage those differences. And then at the level of integration, how do you organize people? Because organizing people is super hard if everybody knows that. I mean, it's not that people are mean, it's just that people will group. And then as people group, you have to bring them together somehow. And the only way to do that I found that worked was building community. And by building community means that you put yourself at the center of the community and say, okay, you can shoot. And then people will shoot you, and then you have to be able to resist until people start to trust you that you know what you're doing. Sometimes you don't know what you're doing, but you have to get to that point. Integrating the process, so the processes, this is, I think, a big problem, is that big companies have big processes based on assumptions. Often they are legacy, and then you try to install the process, and the process doesn't work. But you have a department that is responsible for that process. So how do you fix that? Because if you kill the process, you kill the department. So it's very difficult. Method integration. So how do you integrate the methods of development? Tool integration itself, like I said, big problem. So you have all these technologies. Some are 20 years old. Some are 10 years old. Some are from yesterday. They talk different languages. They have different APIs. They talk one just spits out some text files, and the other one gives you some JSON, and the other one has an API, and the other one has something else. I mean, and you have to put that together. And then the data integration itself. So we have the problem that when you have big data at these levels, it's huge, and you have hundreds of users, it will diverge necessarily. There is no. So you can only either say, well, I will fix this by blocking people and saying you cannot do this or that, which people don't like. It's very difficult. You have to monitor, you have to give the capability to monitor the data at all points so that people know, but then you have to show them that they made mistakes. And if you show people that they made mistakes, they don't like you very much. If you tell them, you have to fix that, then why should I fix that? The other person should fix it. So you get into these problems. It's really not easy. But, I mean, we did kind of achieve quite a lot. We kind of took all these challenges. So you see, I mean, it's not only a software product, it's rather kind of a culture in a sense that we developed. And we were really able to do things that were just not possible before. Like, for example, measuring trends. So you have all this data, and then this data is evolving across time because hundreds of people are changing it, and you are able to measure some trends in, for example, correctness or completeness or some sort of trend. And we have many trends now, and this has really helped because then when you do these things, it's not only that the people that are developing can see them, it's also that the management can see them. If the management cannot see this data, they cannot decide. They don't know where they are. So you start to have some kind of strange loops that things don't really work together, and people are expecting others to expect something, and then it's without monitoring, you're really not going very far. So this was a big achievement that we were able to get monitoring. This is just an example of what we did, but we did a lot more things. Okay, so achievement, very proud of this. We got this month ago, more or less. So CDR means critical design review. So this means that the plane is going to be built. We know that now. This was not the case 1 year ago. Nobody knew if the plane was going to be built. We were able to deliver. So our team was able to build the system that delivered 1,500 documents to the authorities and said, this is the thing that is going to be built now. and it worked. I mean, it's not perfect, but it worked. So this is kind of the first part of the story. It was really very, I think it was the most difficult thing that I've ever done in my life, to be honest. And I mean, so there are people who did amazing things. It's difficult to quantify this, but we really kind of achieved something quite extraordinary, I think. It's something that, I mean, I don't want to brag, but it's something that I'm very fortunate to be able to have done. And I think now we're going to go into a phase where we're going to build this aircraft. How efficient that construction is going to be is a different story. How much money we're going to put into it, it's a different story. But it is going to be built. Okay, so yeah, I mean, we still have a lot of things to do. This is great. We have to automate more. We have to integrate more. We have now the big challenge is making sure that the architecture remains stable and that the change is controlled. Because when you start changing things, you can regress. And that is the main problem, that we don't want the architecture of the aircraft to regress. Okay, now that was the part of Airbus. Now, my private experience with AI. So I started, like I said, I started maybe seriously 6 months ago, and I did my PhD a long time ago already. In maybe some of you know formal methods. This is kind of a subset of computer science that worries about, let's say, helping building software in a very correct way. Let's put it like that. So it's very mathematical heavy. So I did my PhD in that, and I studied a formalism at the time called Algebraic Petri nets. And at the time, there was a big problem, is that, and maybe some of you who are in research or have been in research know this, it is very hard to build a prototype in research. Extremely hard. The reason is you can have a really nice theory, you can be in the details of all your maths and know everything, but then when you go into building a prototype, maybe you are not the right person to write that code. Maybe you are, but then if you are, you need a lot of cognitive load to be able to do that. You need to really kind of dig in. You cannot just say, oh, I'm doing this on the side. No, it's going to be a project. And that project deters you from doing your theoretical work on your PhD. So it's kind of a big conflict. And people may say, well, we get some students and the students will build that. I mean, maybe the student is good and you're lucky and they will build it. Maybe you're not that lucky and maybe the student goes in 6 months, is good, it's built something, but then you don't know how to fix it afterwards. And you're really kind of running into a problem here. So I wanted to see if I could replicate the things that I would have liked to have done during my PhD just using vibe coding. So vibe coding, for you, probably several of you know what it is. You don't write any code, you just prompt. So, I mean, I'm a software engineer, so I know how it works. But the goal here was we deliver at Airbus a professional level product, and I wanted to get a product at that level privately built, for this editor. This went through several releases of models. So at the beginning when I started, it was still Claude 3.7, I think. And now I'm in Opus 4.5. So, I mean, these are just the Anthropic models. I mean, in the meantime, I went through GPT-5, I went through Grok, I went through several ones. But I see that what I felt is that it is now probably around 1 order of magnitude better than it was 6 months ago. Because at the beginning, when I wanted to tell the code, please refactor something, it would go around and spin, and then I would have to revert my code, and then I would have to ask it again. It would not converge very easily. And now it pretty much one-shots it, or two-shots it. And I'm talking about a big code base, like 40,000 lines of code. And it just does it. I mean, at the beginning when I started doing it, even with 3.7, it was like, I was feeling like I was not in this world anymore. It felt like kind of an extra experience where, is this magic or what is happening here? And now I still have this feeling when I get new models that I feel, well, this looks like magic. It's like, how can you do this? You know, because this is the same thing that it would take me 3 weeks to 1 month to do, and it does it in 1 hour. Okay, it's crazy, yeah? And the point was, you can always say, well, but you cannot get to professional level with this. This is just a toy. Yeah? So I tried to explore that a bit. Yeah? So I tried to use AI for my private coding for requirements, for product and feature planning, for feature development, integrating with external libraries, big plus there, integrating with external libraries. It's a huge pain to do that. And it does it like it did it in 1 hour. It got integrated. Yeah? I'm like, okay. Bug fixing, extremely fast. Architecture and refactoring, I asked it to refactor my code 3 or 4 times, and it did it. Like touching tens of files and then restructuring the code, and then it ran. Like, okay. Test-driven development, so this is the professional part. Yeah? Even in aerospace, the way that you certify something is mostly with tests. This might be a surprise, but it is. Mostly with tests. There is a little bit of formal verification, but it's mostly tests. So if something, and I've certified software before, and what I did is that I made a test report and I showed it to the authority. And the authority said, yeah, okay, this and this, maybe improve this. And then the software was certified by tests. So, of course, the authority did not know which code was written. They just saw the tests. So if I show this and I say I have, and then I was able to build 700 tests, so 500 unit, 300, 200 integration tests that I know are real. And then I go to the authority and say, look, here are my tests. Here is my software. Will the authority know if it was written by me or by you? No. No. So, I mean, and if it works, sure, it's statistic. There'll probably be problems. But if I wrote the code, there would probably be problems also. Right? It's the same story, yeah? Yeah, so, I mean, it did all this. It did front-end development. It did front-end, back-end, touch. So my app is running on my phone. KPI generation, monitoring, builds, cloud deployment, everything. So I would estimate that it was around a 10 times speed up. It would take me around 1 year to build this full time, I think, if I had to learn everything. Because some of the technology I just don't know them, they are new. And I did this after I put my kids to bed. So after a work day, I could still come home and build this. Yeah? And I would not be able to code after a working day. It's just too much overload. You cannot cope with it anymore. Yeah? But you can do this. So this is, I mean, I'm very proud of this, so I'm showing it to you. This is on the right is running, on the left is running on my phone, and this is the thing that is running on the browser. Yeah, so it's pretty. I find it advanced, and it's something that did not exist 20 years ago. It just did not exist. People were doing research on this stuff, and there was nothing like this before. It was buggy, it was bad, it did not get any support. This is running on your browser, this is running on your phone, and it works. And it scales. Yeah? I mean, this is one of the things that also blew my mind, is that these things are very heavy to run. Yeah? And I asked, and I did a round of improvements and say, okay, now it's slow, can you please speed it up? Yeah? And it actually looked at the algorithms and say, oh yeah, this algorithm is ON square, yeah, but I can make it ONK or something like that, yeah. And it did it. And it went from running something over 2 minutes to 2 seconds. And it did it. I mean, okay. Okay, so now we kind of finish this part of the story and go back to the Airbus also. So, I mean, I won't go into any details of what is done at Airbus on this because I cannot, but I think what I can say is that there are low-hanging fruits, there are mid-term gains and long-term gains. Yeah? So the low-hanging fruits would be immediately RAG, and we don't have this, unfortunately, yet. We don't have RAG. Not at the level of security that we need it to have. So we have some RAG outside, but not inside the security environment. So we cannot use it. And this is really, really bad because we have over 1 million pages in documents that we cannot cross-check. So this is the immediate low-hanging fruit, and everybody knows that. Yeah? So people are even thinking about buying some NVIDIA chips and just install them. Yeah? The other one is that we are writing a lot of software. And if I see that you have a 10 times gain at least, and we are on a program's critical path, and the stuff that we are doing is kind of make or break, and if we don't get it right, and we have a few months to do it, and we could have AI to do it, but we don't have AI to do it. I mean, it's really, it starts to kind of mess with your system. Yeah? I mean, you know that this is possible, and you know it's doable, but you know that you cannot get it yet. This is a big issue, and it's not only the software development, it's also getting the people up to speed with the software development using AI, because it's not the same thing as your traditional. This is something that I learned also. It's not the same thing. It's, of course, if you have the basics, it's good, but and it's important, and it's probably indispensable to have the basics. You still need to be an engineer, but you need to think a bit differently. It's not the same thing. The midterm gains would be, you know, if we get AI to assist us in the model development for the aircraft, you could do some predictive modeling. This is not integrated with the tools yet. There are some attempts, but they're not yet there yet. Data integration, so again, something that is very difficult to solve because all the different technologies, and I think AI could really help us here to get all the tools and all the formats together, APIs, and all those things. We have many processes that unfortunately are manually driven. When people say, well, it is digital, but you still have to do it manually. It's like that, actually. We are at this point where you have data that is digitalized, but we're not integrated it yet, which means that many things have to be done manually. And then you lose all the gains, unfortunately. Yeah? And then this is where I think AI could really kind of give a hand. And then the long-term gains for me, I mean, we really, because we are so big, when we go from program to program, some people retire. Some people go away. These people are the people that had the aircraft in their heads. There's only a few of them. Yeah? And when these people retire, the rest, maybe they can, maybe they cannot. It's a shot in the dark, actually. You don't know. So maybe you are lucky and you get somebody who can, but this kind of conscience of we went through all of this and now we can bring it forward, maybe this is something that AI could help also. Yeah? So to finish up, what are the risks and what are the opportunities? I mean, I'm going to be a bit blunt here, but for us, because we're military, we build military hardware, there are risks, important ones, and one of them could be that the first mover takes most of or all. And you see this already, for example, Anduril, if you know, from the US, they're big, they are software first, they don't have legacy, they can just go fast. We have also the risk of heavy disruption on legacy ways of working. And I mean, there was a previous talk about people. Yes, we need to take the people, but I'm not so optimistic there in the sense that I think some people will just become redundant in a certain sense, explicitly or implicitly. Yeah? I think first it will be implicitly and then it will be explicitly. And I think that will happen, simply because it goes too fast. As humans, we are very difficult. We are much slower than this. And the opportunities, again, first mover takes most or all. So if we are the first mover, we can take a lot. And I think an opportunity here is also, maybe not everybody agrees with this, but I think AI is an equalizer, in the sense that we can start again from everybody's at the same level. There is no big advantage. No? Then the big advantage will be who can build on it first. No? Okay, so thank you. Sorry?
Thank you.